nearly 20 years in distributed computing and related technologies. Please welcome the CTO of NuoDB, Seth Proctor.
Who said small swan? No, I mean like points for creativity, but like really? Okay. All right. Is that better? That's better. Okay. Yeah, so one of the important qualifications of being a CTO is understand core technology, but we have to set something in the presentation. There we go. Okay. Thank you all for coming. I hope this is going to be interesting for those of you who have come to a few of our talks before. Some of our talks in the past have been kind of really gory, deep dive into the architecture. We thought we'd try a slightly different approach today. And what I want to talk about a little bit today is kind of a topic that I think gets short shrift a little bit in the database world, which is really more about how do you is really about kind of working effectively with your databases. So how many people in the room have seen Ocean's 11? Like the remake, not the Rat Pack train wreck. Yeah, okay. So there's a scene early on where George Clooney and Brad Pitt, mysteriously turned into good actors in this movie, are pitching their plan. They're all like, it's going to be really complicated, it's going to involve like lots of moving pieces, lots of people, you know, it's going to be like this crazy thing that no one's ever done. And the guy they're pitching for the investment's like, no, it's been done, it can't be done, like, you know, it's ridiculous, it's complicated, other people have tried it. So he goes through this like top 3 list of what's happened, and then he kind of gets to the punchline, and he's like, but lest you forget, like, you get the money, that's great, you're still in the middle of the exploited deleted desert. I feel a little bit that distributed systems are kind of the same way. That like distributed systems are wicked complicated, they've got all these moving pieces. It's very hard to think about how you put them all together. It's very hard to get all the right people on the same job to really build out kind of amazing, complicated technology that somehow all fits together and somehow works. And once you've done that, people then often lose track of the fact that you've built this amazing piece of technology, but you don't figure out what to do with it. Because it's got all of these very complicated moving pieces, and it requires someone who's kind of on par with the developers to really build it. At the risk of dating myself, how many people in this room have deployed things on Genie? Corba? DCE? Good Lord, I am dating myself. Okay, at any rate, right, so by the extremely scientific process of getting a show of hands there, it's clear that a lot of you haven't actually tried to work with a lot of these distributed systems, probably in large part because they're really complicated, they're really hard to work with. And what we're talking about today is we're talking about this thing, NuoDB. And I'm actually going to be showing you some brand new things we've just done. Wednesday last week, we released the 2.0 version of our product, which we're pretty excited about. And what is NuoDB? It's a lot of things. You all answered a lot of good answers to trivia questions, except possibly for the small swan comment. So you clearly have some idea of what NuoDB is. But this is kind of the one-sentence summary I give, right? It's a distributed database. It's a database that does all of the things that a relational database does, but it runs on lots of machines. And there are lots of reasons that you want to distribute a database. We'll talk about those over the course of today. But generally, you distribute a database because there are problems you're trying to solve. You care about high availability. You care about throughput and parallelism. You care about being able to run in multiple places with low latency. You care about different management models. You care about reacting intelligently to different failure models. And when you distribute something, you're taking something that runs on a single machine and you're running it across a lot of machines. How many people in here have deployed something on Amazon? How many people in here have been bewildered by a failure they've seen on Amazon? Really? Come on. Really? just like your experience on Amazon is like 100. I mean, I don't want to pick on Amazon. It's like every cloud provider.
I've only worked in one AV, so.
Okay. All right. Well, distributed systems, have the commonality between all of them that they fail, and they fail in crazy, interesting ways. And so, usually, deploying a distributed system is an exercise in really thinking very carefully about where everything runs, how you react to failure. It means setting up a lot of redundant systems. It means setting up things that are very complicated to get ahead of the failures you're going to see. It means tuning things and tweaking things. And kind of the way I look at it is, if you don't provide a user a distributed system that out of the box is thinking upfront about the usability problem as much as it is about the technical scaling problem, you've got a system that no one's going to be able to use effectively. And so that's kind of what the talk today is going to be about, is how to make sure that once you build a beautiful piece of technology, you don't find yourself in the middle of the desert. A couple kind of key things about the architecture for those of you who haven't looked at NuoDB before and aren't familiar kind of with what our kind of key architectural features are. So first and foremost, I think the architecture for NuoDB is designed to be something that is fairly simple and is designed to be composable. There's no single anything, there's no kind of special computer in the system, there's nothing that is configured differently than other things. It's really a true peer-to-peer system. And it's a peer-to-peer system where all of the peers are the same executable, so they all have kind of the same functionality, they can speak the same protocols. They play one of two roles. They play what we call a transaction engine, or they play a storage manager. By the way, I apologize for the colors. We had until last week 2 kind of official brand standard colors that I was supposed to use in all my talks. We now have 3. We're pretty excited about it, but green is not just what's those earphones. Green is kind of our corporate passion, and as a result, a lot of our slides are like green on green, and I'll do my best to kind of illustrate as we go through what's actually on the screen here. Transaction engines are processes that understand that they're speaking SQL. They know how to speak to SQL clients. They understand 3 of the 4 rules of ACID. They understand atomicity, consistency, and isolation. These are in-memory processes. So when you're working with the NuoDB database, you're actually running against something that is at in-memory speeds. It's also a caching tier, so it kind of, one of the nice usability things out of the box is you would never have to deploy an additional caching tier on top of our database. The other role here it can play is what we call a storage manager. A storage manager is something that understands the D in ACID. It knows how to make data durable. It knows how to give you access to that durable data when it's not available in that caching tier. And so there's a very simple kind of, when you start thinking about how do you build a database, there's this very simple building block. We have these, really only these 2 things you can use, and you can decide kind of how to start hosting a database based on this. And I should mention, for those of you who are substantially younger than me, and this is really important, our durable store is actually, because of our internals, and I'm happy to answer questions about it or take questions offline afterwards, but because of our internal architecture, our durable store is really just sitting on top of the key value store. So, on the local file system, this could be against the local file system. If you're deploying on Amazon, your durable store could be S3, or it could be a combination of VBS and S3, or S3 and HDFS. It really doesn't matter to us. It doesn't affect performance. It's just kind of another deployment issue of how you want to run a database. So what's nice about this is you can start thinking about your database in these 2 tiers. And historically, if you go back and you look at kind of the original kind of system R architectures, and you start kind of at the beginning of where database research, RDBMS research started, kind of where architectures evolved from, there's been this traditional dependency between what's happening on disk and what's happening in terms of processing. And that's really where Jim Starkey, our technical founder, kind of started looking at our architecture. He's really making a clean cut there and saying you should think about the tier where you're doing transactional processing as separate from the storage tier. And among other things, what that means is that when you start building a database, when you start deploying a database, you think about these 2 tiers as things that you can scale independently. You can think about provisioning, you can think about scaling, you can think about management of where data is really durable as completely separate from how you're handling transactional data. And what's really nice is that you can do this on demand. So NuoDB is not a system that internally implements explicit sharding, explicit hashing, any kind of explicit partitioning scheme. And it's a system that presents to your applications the view of a single logical database. So you are not implementing anything with sharding or partitioning. There's no active passive replicas, nothing like that. It looks like a single database, whether it's on a single machine or 100 machines. So already when we're starting to talk about kind of what we tried to do in terms of this composable model, one of the things we tried to do was make it very simply programmed. A lot of people kind of often lose track of this, but it turns out developers are also users of software. So when you talk about usability of software, you have to start by thinking about the developers who are writing against it, right? So that's kind of the starting point here. What does on-demand mean in our case? Well, it means a couple really nice things. You literally, when you're running our software, can add, move, or remove transaction engines to a running database. We actually do this to storage managers too, but I think it's more interesting for the purpose of this talk to talk about transaction engines. Why would you do that? Well, kind of one obvious one is you've got a database that's distributed across 5 machines, and suddenly, like, your website becomes the thing that it becomes wicked popular, and you're not keeping up with the load. And what you need is you want to scale out your web tier, and you want to scale out your database tier to be able to handle that same transactional throughput. And so you can literally just do that on demand. Click on something in our UI, you can script something, you just add more transaction engines on more hosts. There's no reshuffling internally, there's no rebuilding anything. It just expands. Usually in about 100 milliseconds, you've got a new transaction engine running that's active, that's taking on load. You'd also do this because you want to do live migration or live upgrade. So we actually support a mode where you can upgrade the operating system, upgrade the hardware, migrate to new systems, upgrade the NuoDB software, never taking down the database. This is designed to be something that's always up. So again, from a usability point of view, it's not just your developers, it's also your operations people, right? It's also the people who have to think about how do I maintain a database, and it's your application developers who are thinking about what's going to be the implication of having downtime. So this is a system that's designed to never have to have downtime. And obviously, the other thing that lets you do is it lets you readjust resources. So you deploy a database, time passes, and you discover it doesn't need as many resources as you thought it did, or it needs more resources. Or maybe what you've discovered is that you can run something more efficiently because you brought some new piece of hardware online and it gives you much more power for much less cost. So you can just move to that. The on-demand nature is also something that applies to our durability points. So this is kind of a quick flow chart that shows you that I can have a running database with a single durability point, and just at any point while it's running, I can say, you know what, I want a full independent replica of my database on another host. Maybe that's for kind of faster performance, maybe that's for disaster recovery, I just want to back up. There are any number of reasons why you might do that. You can just start a process, and it will start up, and it will start communicating with the database, and when it's fully synchronized with the active state, it will become an active participant in the database. From a programming point of view, you don't see anything about this happening. You don't see the database in a partially synchronized state. You don't see any inconsistencies. There's no like replication delay going on here. It still looks like a database, right? And so from a programming point of view, you can do some really nice things at an operations level that don't affect your application, don't affect what your application developers have to see. Ditto, you can react to failure really efficiently. Something fails, you can recognize that, you can automate this, bring something else back online to take up the slack, basically, and you're still off and running. And that's actually something I'm going to show you later in this demo, is that this is kind of a property of a database you really want. Part of the reason we can do that is because the software is a lot more than just a database. It's also something that has a management model, and it's also something that provides multi-tenancy. Someone was asking me before the talk about kind of taking the software and using it in a service model where you have a lot of people who are coming to you and saying, I just need a simple database up and running. And that's actually a use case we support really well, because when you install NuoDB, what you're doing is you're provisioning a host to run one or more databases. Right? The question came up earlier about multi-tenancy. Like, that's an important feature of the system. But the point is, what you're really doing is you're getting a host provisioned in the cloud provisioning sense into a pool of resources that can run your database or your databases. And some of these hosts you're going to configure what we call a connection point. And just like the peer-to-peer nature of the database, the management layer is also a peer-to-peer system. There's no central anything, there's no single anything. And so it's something where you can bring things live online, have things fail, have other things pick up, and that's what our software does for you. These connection brokers are there to do load balancing, they're there to provide management, and as we see later, that single point of management is really powerful when you start distributing further and further apart, and you really want to see everything from a single point of view. And here's just kind of a quick view. When I'm saying multi-tenancy, what I'm really saying is that we can provide a multi-tenant model where, from a single management point of view, you can spin up arbitrarily many instances that are just this composition of, I'm going to take some transaction engines, some storage managers, and I'm going to decide where to run them based on which resources I have. And they're going to be able to just take advantage of the hosts that are available in what we call a domain collection of hosts. And they can be running mixed combinations of storage, they can be running mixed hardware, mixed software, they can be running on-prem and in a public cloud at the same time. You get a lot of flexibility. Right? So when we're talking about kind of usability of a system, I think one of the first things you want to think about is kind of, is the system going to be usable from the point of view of the people who have to deploy it, the people who have to actually maintain it on a day-to-day basis, and then the people who are going to program to it. And part of the reason I have this picture up here is because this is a fairly simple deployment. We have people who've done like wildly more complicated examples, but this is already starting to look complicated. It's already kind of, there are lots of moving pieces. How would you know where to put things? How would you know where to co-locate things or what things should be isolated? How do you know when something fails? Which is the right thing to bring up? How do you track where your storage is? And so this is what I'm talking about when I'm saying you start building distributed systems and you can have beautiful, elegant architectures, but if this is all I gave you, it's not enough. You can't really build out large systems like that. Yeah?
Just to clarify this is all the hosts are independent, like either physical or virtual hosts,
Yeah.
and then that direction are the actual...
That's right. So this is a picture of 6 independent hosts. In this case, I've set S3, so this is probably on Amazon. So 6 instances, 3 independent databases that run as, truly isolated databases. There's process level isolation. They're using different credentials, so it's different security models, different physical locations of the data, but they're all shared resources. And for those of you who are really curious about how far we can push that model, I'm not going to really talk about this today, but we did an experiment back this winter with HP on a new piece of hardware they rolled out, something called Moonshot. It's a collection of a whole mess of Atom processors, basically in a single box. And it's kind of cool because it's really efficient, it's really low energy, but it's also, in their first iteration, really, really, really low processing capability and memory. And so what we did was we decided to do a simulation around kind of how many real-world databases could we put in a single machine, and how efficiently could we work with that, how could we talk about the total cost of ownership of something, go read about it. We did a simulation of kind of what it looks like to host WordPress blogs in the real world, and thought that on the 4U box we could host about 80,000 individual tenants, which we thought was pretty cool. So, yeah.
Is it Atom process or ARM process?
Sorry?
Is it ARM process or Atom process? I believe it is an ARM process.
The Moonshot is
Yeah.
Atom. It's Atom processors, yes. When the original bought the hardware and started building it up, it was ARM. They switched it before they went to market. So it was the new 64-bit ARM was in the first iteration. They just revved it. So, all right. So that's a really, really quick version, kind of something about the NuoDB architecture. And to give you a little bit of a taste of when I'm saying a distributed database, and I'm talking about kind of why distributed systems start getting complicated, what I'm talking about. So what I'd like to do now is I'd like to switch off the slides for a second. I want to give you a few examples in practice of what we're providing and kind of where we're going and why I think there are some solutions to some of these problems. So first thing I'm going to show you is, can everyone see that? Sort of? Okay. So this is a new kind of prototype tool we rolled out in our 2.0 release. It's kind of, if you've used our software before, we had a web console that kind of was let you dig very quickly into the gory details of all the processes that were running in the host and look at very low-level stats and kind of manage everything on that level of transaction engines and storage managers. a new view we have which tries to simplify this, which tries to say, kind of no matter what your deployment model is, we can give you a very simple rolled-up view of all of the machines that you have provisioned, and something about the activity across those machines. So this one right here is actually running against my laptop, right? Again, from a usability point of view, if as a developer, I can't take a piece of software and throw it on my laptop and go sit in a coffee shop and do development, I'm not going to be very productive, right? And so this whole, like, we can provide the view of a single logical database means you can do that. You go to development somewhere, when you're ready to deploy on a 40-machine scale-out system, you're not changing your code. It's the same thing. So you can install the software on your laptop. Everyone should go to our website. Our marketing team would kill me if I didn't say this. Go to our website, download the software. It's free. You can install it on Windows, Mac, Linux. You can run it on your laptop. You can run it on, like, cloud. You can, you know, it's a floor wax, it's a Xer topping, there's all kinds of great stuff. But it's small, right? It's like 20 seconds. It's installed on this machine. I've got this console up and running, right? Very simple. And what I'm going to do is I'm going to show you something that looks very similar, right? And hopefully by the time we get to the end of this talk, you'll appreciate kind of why this very simple thing I've done is kind of the point. That there's not much of a demo I can give you, and that's why kind of we're on the right path with our software. I'm going to, let's see, I'm going to create a database called Small Swan. I'm going to give it a DBA username and password. For those of you who have used RDS on Amazon, by the way, this should look kind of familiar, right? That's kind of the point, is that it's meant to be a very simple, streamlined, familiar way of interacting with a database. And I'm going to pick a template. I'm going to talk more in a minute about what I'm doing. But basically, I'm going to pick the description of the kind of database I want to be running. Now, I only have my local machine here. I can't do very much with it. So I'm going to run a single host thing. I'm going to say submit. And what's going to happen is I'm going to get a database running on my machine. What just happened in practice, right? What just happened is on my machine, I started one of those transaction engines and one of those storage managers. They're paired together, they're secure, they're running. I've now got a durable database running on my machine. If I wanted to, I can, you know, start a second database, the same, same rules. And what we'll see is, you know, I now have two databases running, because as I said, this is a multi-tenant product, right? So it's very easy for me to just start spinning up and spinning up and spinning up as many databases as I want. These are using, in practice, very little footprint. You can see with everything running on my machine here, still, you know, not very resource impacted. You know, so I've got my small Swan database here. It's pretty cool. Not a lot going on with it, but I can kind of see that it's human, right? And I can see that I've got, as I said, I've got this kind of storage manager, transaction engine. There's some complexity here, right? But it's all been kind of nice. It's all been connected. And that's all great, but this is just one machine. That's not a very interesting example, right? So 45 minutes later, the cake comes out of the oven, and it kind of looks like this. So this is the same tool running against the same NuoDB software, but this is now on Amazon. And a couple interesting things to note here. One is what I did kind of this morning was I provisioned a bunch of hosts on Amazon with our software, got them running in one of these systems. And then I used a different template. I said what I want to do is I want to start actually what we call a geo-distributed database. Because what's interesting here is I'm actually running a single database. The network is a little slow. This database that we're seeing live is actually running in both Virginia and Ireland. So this is really right now on Amazon. It's a single logical database that I have that is distributed transaction engines and storage managers, the in-memory processing points and the durability, running in both data centers. Why would you want to do this? Well, one is if a data center fails, your database is still there. And you've got a full, always consistent replicated copy of your data in both places, and I didn't have to do anything to get that other than go into that same thing we just did launch and say, instead of running it on my machine, run it on across these two data centers. The other obvious reason is kind of what the application is here I'm running. So I'm running a demo that we ship with our system, something called a storefront. The storefront is kind of meant to look like an Amazon-like site. It's just a simulation of kind of what a shopping system would look like. But it lets you But it lets you kind of drive simulated load, different kinds of users. I want users that, different kinds of typical purchasers, right? So this is something we include to help you kind of kick the tires, convince yourself that this stuff works. And the reason I'm showing you this is because this is a common problem people have. Maybe not shopping sites, right? But situations where you have users that are distributed in more than one physical location. And you want to give them low latency access, not just to the web interface, but to their data. Right? And when you think about a shopping site, most data actually has nice locality, right? Most data actually distributes very nicely. And so we can run this database, 2 regions. You get high availability, you get good durability, and you get low latency access to your data. And that's what we're running here. It's basically a simple simulation where I've got something driving load in Ireland, I've got something driving load in Virginia. And part of what our software does, again, that usability thing is out of the box. It knows to make sure that that Ireland thing that's driving load is talking to transaction engines in Ireland. The Virginia thing is talking to things in Virginia. If nothing's available, it'll fail over, but that gives you kind of low latency easily out of the box. There's a question.
So when you were setting up the small swan demo, I noticed that you chose single host. And so I'm curious, is this something you can reconfigure on the fly later, or does it, once you've gone one direction, you can't go back?
It is. No, it is. I can't change it on my laptop because I only have a host. If we have some time later, I may ask my fabulous assistant Trek to run the software on his laptop, or get someone else, if someone's brave enough to run on their laptop, and we can try just expanding it on the fly and see what happens. I'm sure that'll just work.
Another way, you're not boxed in from the get-go.
No, and so I mentioned we did a release last week, a 2.0, our 2.0 launch, and we did like an hour-long webinar. I don't think it's online yet. It'll be online soon. One of the things I did in that demo was I actually walked through that. I started a database running as a single machine database. I expanded it to something that scaled out to fill out one region, like all the machines in that region. And then I expanded it to fill out the whole region. So I'm looking here at, let's go back to my machine here. I'm looking at that small swan database. I can just go up here and say actions edit. And I can just pick, now if I pick, like, say, the minimally redundant database, what's going to happen is it's going to tell me that that's an error, because that requires at least 2 machines to meet essentially a service level agreement, and I only have one machine. So until I bring a second, now as soon as I bring a second machine online talking to this one, it'll just automatically expand. Yeah.
When you were talking about multi-region configurations, let's say the web hosts in those places, do they still just talk to one host, or configuration-wise, do you tell them?
You can configure how you want. So there's this
you don't
web
have to get the geographics.
right. So this web tool is talking to kind of REST container that can talk to the same. We were talking about brokers earlier. It can talk to the same brokers that anything else is talking to. And so we have brokers configured in both regions, and we've done different deployments with people. So we've done one-off deployments where they're talking directly to specific hosts. On Amazon, Route 53 ends up being a great solution for having a single name and having it always map to the thing that happens to be closest to you. So that's kind of, again, on Amazon, that's a great solution. Something else I just want to show you. Part of what's nice here, so we're looking at, we can look at the database here that we're actually running that demo against. We can see it's running on, as I said, on 6 machines, 3 in Ireland, 3 in Virginia. It's running 10 processes. That's really exciting. What's nice about having this single point of management now, though, is I can go in here and say, well, show me the hosts. And something you can see is that from one point of view now, I can watch what's happening across all those machines and really see. There's a bug in our 2.0 release. I don't think this graph redraw, so apologize. Were that redrawing, it would be like shifting this way real time. So just imagine that's happening. But you can see, you can very easily start to say, I have a single point where I can be watching not just kind of what a DBA traditionally would do, but also kind of what a systems administrator traditionally would do, thinking about resources across a cluster of machines around the world, and I can do it from one place. So it starts to make it really easy to think about how do I do kind of both the, how do I do both the dev and the ops kind of pieces of the equation. So the last thing I kind of want to highlight here is around these templates that I've kind of hinted at, right? Templates are something new we introduced in our 2.0 release, which basically are a way of defining service level agreements. They're a way of saying, these are the requirements that I need for a database. This is a problem I'm trying to solve, and what I want you to do is I want you to automate the process of being able to start a database that meets these requirements, and then I want to make it easy to monitor and make sure that my database is still meeting those requirements. And if some templates you can write to be fixed, so like run just on this machine. Some databases like that multi-host one will expand automatically to run more transaction engines as more hosts are needed. And they'll recognize when there are failures and either try to bring something else automatically to pick up, or they'll recognize that something has failed and you can't meet your requirements anymore and they'll notify you. So they're a way of starting things, they're a way of automatically kind of expanding to meet requirements, and they're a way of very simply helping you kind of make sure that your databases are running, which on a single machine may be easy to do. We have customers right now who are doing deployments where they have single databases in every region in Amazon. Like one database running across every region in Amazon. This is not a nice to have it. This is if you don't have something like this, you can't do that kind of deployment. It's just too hard to think about those kinds of systems. And what does, just going back now to our slides, so templates to me are kind of a critical piece of what we're doing. Because what we're really doing is we're starting to make into this notion that you have to have this systems administration idea. You have to have this ability to define what the criteria are for this. And what does a template look like? A template is really a very simple declarative structure. And here's a simple example. When I selected run a database on a single host, what I really did was I said, I want a database that is going to have a single storage manager, is going to have a single transaction engine, and I'm going to run it on some known host. So if you were paying attention when I actually started that small swan database, one of the things it prompted me for was a pop-up saying, which host do you want to run this on? Right, so this is a way of saying I want to start a database, and I want it always on that host. Like if that host goes down, don't try to bring up the database somewhere else. Just like wait for that host to come back up, and then restart the database on that. So it's kind of pegging the database somewhere. Perhaps a more interesting one is the multi-host one I mentioned, something that scales on demand. And this is something that lets me say I want to peg a database to a particular region. So that's that variable there, region. That should have always at least one storage manager. If possible, I'd like two. I'd like two independent points of data. And I always want to have at least one transaction engine, but if there are more hosts, run more transaction engines. What we're trying to do with this format is take kind of the common rules that we think people care about when they actually do deployments today. What are the problems they're trying to solve? Is it about scale? Is it about fault tolerance? Is it about redundancy? Is it about low latency? And encode them in very simple syntax so that you can actually sit down and say, well, this is close. This is almost what I want, but it's not quite what I want. And you should be able to go in there and define your own templates, to define the rules you want so that when you say, every time I start a database, I'm a service provider, or I deploy databases in my organization, or I need to test against a particular kind of database all the time. You can write a template, you can upload it to our system, it's in our durable state, and then anytime you want to start a database, you can just start it against that. Let me show you what I mean by that. Again, I realize I'm dating myself by having Max be the thing that bring on. But so, for example, I'm just going to do a quick little curl command. So I said we have the UI built on top of a REST interface. Right. Part of what you can do with that REST interface now is you can actually take advantage of all the stuff I'm talking about. This isn't functionality that's baked into the UI. This is functionality that's baked into the core of our architecture. And this is something you can distribute and you can can run these kinds of operations from anywhere across your cluster. Right? So I can say, show me the list of templates that are available. I could put a new template in if I want. I can also, similarly, I can say, show me all the databases that are currently running. And that was against this local machine, and so we can say there are, we can see there are 2. You sort of see there are 2. Trust me, there are 2. And if I want to start a new database, let's say I want to start a database that I've decided to name right there, patch demo, right? There it is, a single curl point, right? And what I just did was I said, I've got this template in there called single host. What I want to do is I want to instantiate a database against that template. If we go back to here, what we should see, I don't know what I just did to my small code, right? There's our patch demo database. And it's running. It's running as expected, right? So, kind of what's nice about this is we've taken all of these rules about how you very easily define kind of your criteria for databases, but then also how you work with them, how you make sure that they're running, and how you start them or stop them or quiesce them or do whatever else you want to do to them, expand them. The question about upgrading a database, that same REST interface, all you do is you go in there and say, retarget this running database to a different template. So that's something you can script at that level. You can use our Python APIs, you can use our command line tools. We have Java APIs for doing this. There's kind of different ways that you can hook in with it, but it makes it really easy to say you're going to kind of manage everything that's running. All right. Let's see. So that was basically what we just did, looking at templates, looking at databases. Something else that's interesting in here, kind of again from a user experience point of view. Right? We couldn't automate all these things. We couldn't make it easy to work with something across the system if we didn't have statistics. Right? If you don't understand what's going on in a system, you can't automate it. You can't manage it. You can't make intelligent decisions about what your system should do. NuoDB has always had kind of low-level statistics that were being collected across the cluster. Things associated with each individual process that we're running, things that were associated with the host, events about the different components that were coming and leaving. What we've done in our 2.0 release is we've actually started collecting these statistics into a database. Again, this is a multi-tenant product, and we just kind of to make life easier for you, we don't show you here that we have this database running, because it's always running. But if you decide to skip the pretty GUI and you go down into the command line, you'll see something about everything that's currently running on my laptop here, my powerful cluster of one Mac laptop, which actually probably is more powerful than the first clusters I ever programmed. There it is. And you'll see there's that small swan database we created, the second database, the patch demo, and there's another database we have running, the NuoDB system database. And so what we're actually doing is we're taking advantage of the fact that NuoDB is a multi-tenant product, and we're spinning up a database that's there simply for the purpose of collecting statistics. And it's collecting statistics about everything that's happening. So we can look here. We also, if I was going to change and rather than target the system that I've got running locally, if I was going to now take a look at what we were just seeing on Amazon. The same command. There's a whole lot more running in that demo I was doing. We're going to see there's those 6 machines. We're going to see there's that database with all these different processes. And we're going to see there it is again. There's this NuoDB system running. And what that database is doing is it's collecting stats about everything that's running. So it's collecting stats about all the databases, all the processes, all the individual hosts. So it's getting like that let you do these nice automation things, that let you draw pretty graphs. But we're also going to be exposing to you what that schema is, what this database looks like. So that when you start thinking about what is it that you want to do across a cluster of machines, like maybe that GUI is exactly what you want. You want something really simple. Maybe the REST interface is what you want. You want something that's still pretty high level, easy to script to, easy to program. Maybe you're a DBA who really wants to be able, from an SQL point of view, to see what's happening in your system with the same kind of expressiveness or more. So, for example, talk about that later. So like, let's say, for example, what I'd like to do now is I want to actually look at this database that I had running on Amazon. All right, so here's my...
Before you move on from this, what are the two, for each one of the, like the transaction, what are the two different, like the IP and the IP address?
Yeah. So on Amazon, anyone here who's done deployment on Amazon knows that when you start a machine in Amazon, you have a private IP address. And Amazon has a system that gives you a public address. And so what we do is we let you just switch on a flag that says, I'm running in Amazon, talk to the REST interfaces, pre-configure your host with a bunch of this kind of information, things like region names and things like these alternate addresses, so that from outside Amazon, I know how to talk to everything that's running inside Amazon. But inside Amazon, everything's talking to each other. So it's just a way of bootstrapping kind of, everyone has those, different ways that you're traversing different networks. So there's a question over here, I'm sorry, what was...
So is the systems database on all the different hosts that's
So in this case, the systems database is actually itself a managed database using one of these templates. And so what I'm running here is just a simple version. I'm saying just run it in one place. But that's something I also could say, I'm going to run a custom template that says run one transaction engine in every region so that you get very low latency to do reporting. And then maybe just like put durability in one place, because maybe I don't even care about durability. I just care about having, however much live data there is. So that's actually something itself that you can kind of choose how you want to manage it. Just going to go ahead. So I'm actually now connected to that on Amazon, the stats database that's collecting information, right? So I can say like, so we have a schema of metrics, and so I can do a query. For being the CTO of a database company, like SQL is definitely not my forte, I will admit. So this is kind of a wonky query I've created. Latency you're seeing, by the way, is more the latency into Amazon based on how I've written this query than anything else. We'll see if I'm killing me. Live demo, there it is. Beautiful. Okay. So there's an attempt to write something that just says, like, over the last 3,600 seconds, what was the average number of commits per second? Right. That's not very interesting. I mean, that's something you should be able to do for most databases. Like, I think what's interesting about it is that what I just did was I just said, actually, this system that includes the commits on the NuoDB system database, as well as this geo demo database that's running. Where there are other databases running, I could get that too. And it's actually calculating that across all of the instances that are running in multiple regions. Right? So from one place now, from a SQL point of view, I can start to think about how do I write different queries. Trek was writing me a few example queries earlier because his ability to just churn out SQL is actually like far better than what I can just bust out on the fly. What am I looking at here, Trek?
This is going to be the least loaded database. It's the over the last few intervals. It's just limiting it.
This is awesome. I was doing this like on the Amtrak Wi-Fi this morning, and it was like coming back like that. And I'm here, not any offense, AOL people, I apologize for what I just applied. Something just spin on. Is that like a reference to slowly? So you can, what's interesting is you can basically be, if you're a DBA, or you're kind of somewhere in between kind of a DBA and operations and developer kind of person, and you're very comfortable working at the SQL layer, and you're very comfortable thinking about interacting with data there, but you want to be able to do some of those SQL queries. Or you're a systems administrator, you should not be allowed to see the contents of any one database, because that would be a violation of policy, of security, of any number of things, but you want to be able to have some basic SQL access to look at statistical information. this is something that starts to give you those capabilities. And again, this is something, much like the template work, that 2.0 was kind of our initial release. This wasn't a like, this is fully baked, we're done, we're moving on. It really was this is a first iteration. These are the things that we think are initially really useful, that help us answer some of the questions we're looking at. And we put it into the product kind of intentionally early because we want to get it out there for y'all to try and give us feedback. Like what works, what doesn't work, what makes sense, what's confusing, what questions would you like to be able to ask, what kind of templates would you like to be able to create that you can't create. Like that's really kind of why we're doing this. And so what's going to happen with the next several releases is we're going to continue to iterate on the template syntax, kind of what you can express. We're going to iterate on what is actually embedded in the product. And we're going to iterate on what's actually being collected in the statistics database. And we really want to do that kind of from everyone's concrete feedback. I want to mention just a couple other things while we're kind of going through and talking about what we're doing in our database to kind of help with the overall experience of using the distributed database. And one of them has to do with, stored procedures are like, not just like non-sexy, it's like everyone's going the other way. Like, according to the 23-year-old in our office, kids don't like stored procedures anymore. Jacob is a godsend. He's the guy in the office who sanity checks and done everything I want to do. But we've done something kind of interesting with our 2.0 release, which is we've taken our stored procedure support, and we've added the ability to write arbitrary Java code. We're a scale-up database. We're something that on demand you can just add new transaction engines, and with no sharding, no shit active passive, you just have a single database that's just scaling and running on more machines. And when you squint, that looks a lot like what you do when you say, I've got 5 web containers running, and load just went up, and so now I've added 2 more web containers on 2 more servers to scale it. Right? And when you're doing that, what you're doing is you're scaling out your container to get more places where you might run Java, or you might run .NET, or you might run a V8 engine, or you might run any number of kind of managed languages. And so what we're experimenting with here is saying, well, what if that was something you actually got in the database? What if by scaling out the database, you were scaling out something about your application team? You got something that was still transaction consistent, that was being run correctly, a transaction model. But what if you could flatten the number of round trips between your application tier and your database tier? Minimize latency, minimize kind of the complexity of a query. Or what if you want to do things like, say, I'm managing firewalls, I'm managing routing rules, I'm managing session information. And when I update something in the database in a transactionally consistent way, I need a trigger to fire that's going to update something in a remote service. So we also support Java triggers. And so that's something that some of our customers are doing today, is taking that to basically say I can have a transactionally consistent way of talking with arbitrary external services using languages that I've already programmed to. I was corrected before this talk. Apparently no one still programs to Java. I do. I'm an old Sun guy, so I love programming to Java. If you also love programming to Java, this is great. If you don't like programming to Java, good news. Java is just the language we chose first, and we're probably going to look at other languages too. It's pretty easy to think about folding in additional languages. So again, give us feedback. If there are things you'd really love to be able to do with this, that's something that would be really nice to hear. The last thing I just want to add is, because this usually comes up when you start talking about relational database architectures. And people say, yeah, relational database is great, but what people want today is they want schema-less solutions. I would argue no one wants a schema-less solution. No one wants data that's just like raw data, right? Everyone wants structure. They just want something that's flexible. They want to be able to say, I made a decision today, and then a week from now I realized it was the wrong decision, or a week from now something has changed, and I need to change something about the way my data is working. I don't want to run some operation that's going to cause me to take down my database. I don't want something that's going to take a week to run. I don't want something that's going to cause all my transactions to abort. I didn't talk a lot about the internals of our architecture. One of the important elements of the internals of our architecture is that where we're maintaining ACID, where we're actually doing data consistency and replication and versioning and everything else, we don't see what looks like a relational database. We see what looks like an object system. And how we actually work with SQL is basically a tier somewhere in the transaction engine. There's a point where we do translation from any knowledge of the fact that it's SQL to how we represent things internally. And so to us, schema is just some object in the database that defines that map. And so adding a column, changing the name of a column, that's just simply going in and changing one object, basically. And then all the running transactions might not see it, but anything new will get that transaction consistent view. And so one of the things that we're trying to do is, again, from a kind of easier point of view, easy point of how you use our database, right? Is we're really thinking about the question of schema, not just as a, this is a nice to have, truncate things quickly, you can add things quickly, you can change things quickly, but like, what does it mean in terms of people who are used to programming to a schema-less model and want something where they can very quickly keep iterating, keep changing things, but still get a relational model? And I think this is something that you'll hear more and more about as some of the new SQL systems start to evolve, and as you see like what's already happening with systems like Mongo, like Cassandra, like Couch, a lot of the really popular schema-less systems, systems without consistency. A lot of what you hear in their developer communities is how are they moving towards providing consistency? How are they moving towards providing a query? How are they moving towards providing, if not high quality relations, something that gives you a little bit more structure out of the box? And my argument is, as long as you have something that's flexible, but why not use true relations? That's an easy thing for a lot of people to use. We've got some information out there that you may enjoy. If you enjoyed such talks as this one, you might also enjoy dev.nuodb.com, where we have kind of our portal for all things related to technology. Trek and I and other people ran endlessly on our tech blog. We've got a lot of interesting information about the core architecture. We've got documentation, forums. We have a new technical white paper up that you can make your way from start to finish. You'll understand kind of how everything actually works under the covers. We're increasing the number of projects that we're doing in open source. So if you go to GitHub, you'll find that storefront app along with a number of other applications. You'll find our Python drone. You'll find our C# drone. You'll find a number of adapters we have for things like Ruby, for PHP, for Perl. You'll find other kind of example programs we have. We're trying to put more and more kind of into that space. And as we've rolled out 2.0, we're trying to make this much more of a collaborative community. So if there's something that particularly interests you, we document protocols, we document how the REST interface works, we document other things here. Please come here and let us know or take charges and things. And I think that's it. So thank you.
Before we move on to Q&A, we are giving away an iPad mini tonight. Please, if you haven't entered, this basket's going around, drop your card in or drop anything with your name and info written on it. And this will be given away to someone.
The iPad does not have NuoDB installed on it. I'm sorry. Or maybe that's a good thing depending on how you look at it. It's a sealed box. It's fabulous.
Okay, first question of the evening. What? Pardon? Oh. That just passed around. Who got the first good? Yes.
Say I wanted to take the AdventureWorks Microsoft database and put it into NuoDB. How would I accomplish a task like that?
So I haven't tried working with VentureWorks specifically. We have a schema-aware migration tool for relational databases. And so we've done a number of migrations from SQL Server that have pretty much worked out of the box. So basically it's a tool that understands how to do translation of your schema from whatever syntax we support, SQL Server, MySQL, Oracle, Postgres, DB2. That's all we've tested right now. Database. Yeah, people still run DB2. Like, by the way, like on cloud. That's the fascinating thing. Like, it doesn't surprise me because I was in Sun forever. Like, it doesn't surprise me that DB2 is a thing. But like the number of people we talk to were like, "Oh, I'm running DB2 on Amazon." I'm like, "Sorry, you're doing what now?" That's like an awesome conflux of cultures. It's kind of awesome talking to those people because they're like hardcore systems people who also understand everything that's happened in the last 20 years, which often doesn't happen when you talk to the hardcore people like me who need Jacob back in the office to tell me what the kids are doing these days. Those are fun. So we have a tool that does that migration, and then we'll migrate the schema, and then we'll migrate the data based on that schema. We've tried pretty hard to provide a dialect that's standard. Obviously, every database has a slightly different dialect, so your mileage may vary, but for the most part, we found Microsoft migrations have moved very smoothly.
So what if you did things, like obviously you talked about stored procs, but what about like CTEs, account table expressions? Where would you run into the line of like, well, that's just Microsoft stuff that doesn't translate?
So yeah, I mean, we've pulled in a few Microsoft-specific things, a few MySQL-specific things, a few Oracle-specific things that we think are useful, and we're always kind of expanding. We're a development team of about 17 people right now, which for an early-stage startup is gigantic. For a database company is tiny. So we're kind of picking off specific items like that as we come across them. You know, if you have an example of something that is near and dear to your heart, I'd love to hear about it, because that's kind of how we decide which things to go after next. Is architecturally, these things aren't very hard for us. It's usually just a matter of deciding which of the, like we're in the process right now of adding GIS support. So being able to, in New York, say find maybe 5 close to Starbucks, which is like where I'm standing usually. So I mean, we're doing that because we had a lot of people ask us, what about that?
So you do that to be compatible with like PostGIS?
It's a simple
So it'll be compatible with the OpenGIS stuff, right? So there's the small standard, the larger standard. So obviously we're starting with the smallest.
Next question?
We're kind of building off that. Maybe I missed this because I came in late, in which case just skip over it. But in that, following up on that, what languages do we have interfaces and libraries for?
So we have native libraries, native drivers right now, Java JDBC, and also a data source implementation for JTB developers, native C#.NET with support for the Lincoln entity frameworks, with native C++ driver, with Windows and Linux ODBC support. When we ported our Windows ODBC driver to Linux ODBC a few months ago, we were like, man, we made it to the 1990s. This is awesome. we had a customer who really wanted the integration with Asterisk. They were doing a scale-out VoIP solution, and so we had to make that work, and that actually worked pretty easily. We also have layer drivers. Oh, and we have a native Python driver that does the standard PEP 249, I think, interface. We also have, and we have, for a number of these, we have different framework support. So, like for Python, we have Django support for, so we have kind of different drivers. Then we have layer drivers for PHP, for Ruby, and Rails, for Perl, for probably others. Node, yeah, a bunch of other kind of specific language-specific languages.
Great. Next question? Yes.
What do you mean by infinite instances on a host? That was one of the previous questions.
I think it's the point is it's unbounded. The point is it's bounded only by the resources you have locally. So again, the demo we did with Moonshine, each of the Atom processors was a first generation 64-bit Atom processor. There's almost no level 1 cache. There's no level 2 cache. It's single channel memory to 8 gigs of RAM. Very limited processing, and we were able to run under load. We were able to run 200 distinct databases. So that's 400 processes on each one of those processors, with additional stuff going on kind of in the background at the same time. So it's a database that's designed to be able to run kind of very efficiently, very dense, very tightly. If that's kind of the problem that you're interested in, is how to use resources very efficiently. So obviously, everything is finite.
Size of the databases?
In terms of...
Yeah, 200 databases you mentioned. What would be the minimum size? What would be the maximum size of the database?
Well, there's no limit to the maximum size, really. I mean, the minimum size in terms of footprint, the minimum size is usually going to be about 18 megs of memory, I think. It's going to be the kind of minimum footprint for one of these processes. And then, obviously, as I said, we're transaction engines. This is in memory. running against, you're running against an in-memory database. And so it has caching built in, and so obviously we're designed to be able to run much more efficiently, the more memory you give a given database. But if your data set size is fairly small, which it was in this case, we're talking about people supporting hundreds to thousands of log entries. That's not a very big database. That fits easily, you know, in probably like 50 megs, 60 megs of total storage. So the footprint of this was very small.
We have time for just one more question. No, we'll do two questions.
I'll hang around for a while afterwards. It's okay.
Seth will be here for one-on-one questions afterwards.
Okay, I'll hold mine for after.
Yours?
So I'm curious on for databases like MySQL. There's like a point where if you hit like a maximum number of connections, your throughput dies after a certain number. Does NuoDB have something similar? Like
So right, so we have a connection pooling mechanism similar to what MySQL would provide you, so that if you really want to drive a large number of connections to a given database, we can support that. That's not the typical way we think about deployment, because MySQL is really designed to say you have a single machine that's vertically scaled, right? You need more support for more clients, you get a much bigger machine, and then you have many more people connect to it. And our approach is to say you need to handle lots more clients, spend the same amount of money, but get a whole lot of systems, and scale across those systems with smaller numbers of connections. And by the way, your fault tolerance just went like way up, because any one of those machines can fail, the database keeps running smoothly. So that's our architectural design. That's typically how we would approach that problem, especially because then you can think about affinity between how you're scaling your transaction tier and your web tier. So you can actually get like, people deploy where actually like web containers on the same host as transaction engines. You get very low latency. You get really nice properties in terms of failure. But we can also think about that over that.
So is there some kind of load balancing mechanism that would take X number of connections and have to go to different hosts depending on
Yeah, so I'll give you since we're running out of time, I'll give you the very short version of that, which is yes. So I mentioned there's this idea of a connection broker that's also a load balancer for SQL clients. And that's actually a pluggable interface. And so we introduced kind of a new balancer, for example, in the 2.0 software, which is kind of around regions. We've been testing other ideas and things that we want to ship in the product. We're going to be opening up that interface so other people can just program to that interface right around balancers.
Okay, for any other questions, Seth will be here for one-on-one. We're about to raffle off an iPad mini. Does everyone have a chance to enter? Yes, last chance. Okay, mix it up, please. Well, you're losing somebody. All right, cool. Close your eyes, dig in, reach one out. Don't find your own. You got like 6 of them
Just
there.
one.
Just pull out one.
The most complicated drawing, like.
Okay, you gotta read it out loud.
Sao Chow.
That's it. Thank you very much, Seth Proctor, CTO of NuoDB.